go back and watch those later if your connection isn't allowing you to be up live there, Andre. I'm not sure if you can hear me at this point anymore or not. So anyway, this is our last lecture of Unit 1 today. And what we're going to look at is divisibility. The term divisible means divide without remainder. Let's look at some examples. If I have 12 divided by 3, what's my result? 4. 12 is divisible by 3 because it divides without a remainder. 42 divided by 6, what do I get? 7. 42 is divisible by 6 because it divides without a remainder. 23 divided by 5, however, would be 4 with 3 left over, remainder of 3. Very good. 23 is not divisible by 5 because it gives a remainder when we try to divide it. Now, there are ways to get around the remainder, like a fraction.
Recording is on.
Don't count. It has to divide, not only give us a division without remainder, but it has to have a result that's a whole number. If they're divisible or not. Yes, they're up. If I look at something and I want to divide it by 2, how do I know if it's divisible by 2 rather quickly?
Even number.
If it's an even number. And to define even a little bit better, the last digit is 0.4648. So if I give you a number, 278,355. Oops, let's not do that. Do 346. Let's do that one. Is that divisible by 2?
Yes.
It is. Why is it divisible by 2?
Because the last digit.
Last digit's a 6, which makes it an even number. So that is divisible by 2. You know how to tell if something's divisible by 3. You know, it sounds like it would work, but it doesn't. Like 13 ends in a 3, but that's not divisible by 3. It's actually the sum of the digits. So if we look at this over here, what's 2 plus 7? 9. Next digit's 8, so 9 plus 8? 17. Plus 3?
21.
Careful. 20. Plus 4? 24. And plus 6? 30. So if I add up those digits, they add up to 30. Is 30 divisible by 3?
Yeah.
It is. Now, what if we weren't sure? Well, we could take those digits. What's 3 plus 0? 3, right? That's divisible by 3. So
The 0.
that? Okay. That's divisible by 3, so 30 is divisible by 3, so the whole number, 278,346, is divisible by 3. How about for 4? Do you know of any rules for 4? This one's a little trickier. It goes off of, now we'll put it in a different color because it's not very useful. Goes off the last two digits. The last two digits are divisible by 4. The whole number is divisible by 4. Over here is 46 divisible by 4. Not. No. So that number is not divisible by 4. Well, for that rule to be useful, you have to have memorized or at least be able to determine all of the multiples of 4 from 0 to 100. I really don't expect you to have those memorized. So this number, 793,776. 76 is divisible by 4. 76 divided by 4 is 19. So that whole number is divisible by 4. Again, if you're good with quick division, dividing 2 digits by 4 is better than dividing 6 digits by 4 if you have to do the quick division. But it's still not a terribly useful rule. How about 5? How can you tell if something's divisible by 5? Last digit is 0 or 5. You got it. That's one of the easy ones. You're correct. So I might have something like 39,764,835. All I care about is the 5, the last digit. That's divisible by 5. 6 is another one that isn't horribly useful. No, it's actually divides by both 2 and 3. So let's look at this number right here. Is it divisible by 2? Yeah, the last digit was even. Is it divisible by 3? Yeah, we added it up and the digits came out to 30. So it is divisible by both 2 and 3. So that would be divisible by 6. Now notice I looked for the 2 first because all I have to look at is the last digit. Way easier to tell if something's divisible by 2. That answers a no. I'm not going to go through the effort of adding up the digits to see if it's divisible by 3. Again, if I needed to reduce something, if I need to divide something by 6, I can just divide by 2 and then divide by 3, and I've divided by 6, essentially. Same with the 4. I can divide by 2 twice, and I've done. Anybody know a rule for dividing by 7? There actually is one out there. I don't remember where I put it. Actually, I just discovered it. A colleague of mine sent it to me last year. It doesn't work with every number. It only works with really large numbers. Where you take the last digit and subtract it from the first 2 digits or something like that and see what comes up. I don't remember what it is on the spot right now, but it's not a very useful one. There is no rule that works every time to tell something's divisible by 7. It only works, like I said, for a really large number. For 8, do I have any ideas? Look at the last 3 digits to divide by 8. So up here, 776, is that divisible by 8? It is, never mind. So 776 is divisible by 8. I was off. So that actually is, this number is divisible by 8 because the last 3 digits create a number that's divisible by 8.
Would you look at that?
I made a mistake. I had to write it down. At the end of the semester, there'll be a quiz on how many times I made a mistake and on what days it was. Just kidding. I will make a lot of them, don't worry.
I'm going to fail it. It's too much to remember.
Yeah, no, I won't make you back at you quiz. So anyway, for 9, anybody have any ideas what the rule is for 9?
sum of the numbers.
Sum of the digits again, if it's divisible by 9. Now this one up here added up to 30. 30 is not divisible by 9, so that's not divisible by 9. Let's try this one here. 3 plus 9 is 12 plus 7, 15 plus 6,
25,
5 plus 4,
29,
8,
7,
3,
40,
45.
45.
45 divisible by 9?
Yes.
If we wanted to check, we could do 4 plus 5, which is 9. So yes, that is divisible by 9. 39,764,835 is divisible by 9. Now again, not the easiest rule in the world, and maybe not the most necessary. Because if we wanted to divide by 9, we could just divide by 3 twice. Divided by 9. Simpler one and much more useful is 10. What's the one for 10? 0. Last digit is 0. You got it. Got it. So we might have 418,217,930. All we care about is the 0. That number is divisible by 10, by 5, and by 2, without having to look too closely. Might be divisible by 3. Is not divisible by 3. 418,217,931 would be. That would not be divisible. Bigger than 10, there are divisibility rules, but they get more complex as we go. Kind of like the one for 7 is fairly complex.
I have an idea, but it's probably not right.
Go for it.
Like 5 times 5 is 25, which is a prime number.
The thing, you perfect square number. 5 is a prime number.
Oh, right.
Prime number is divisible by 1 and itself only. Nothing else divides it. Another way of defining a prime number is it has no factors. A factor is a number that divides into it. And a factor is something that it's divisible by. For factors, we do not include 1 and itself. So it's only divisible by 1 in itself, and we don't count those as factors. It has no factors at all. Composite numbers are multiples of numbers. Think of composite materials. It's several other materials put together to make that material. Composite numbers are the same way. It's several smaller numbers put together to make that number. For example, 12. Well, 12 can be made up by doing 2 times 6, or 3 times 4,
Or 4 times 3.
or 4 times 3, or remember 1 in itself don't count. But 12 times 1 would work as far as divisibility, but it doesn't work for factors. 6 times 2, or we can split it up. It doesn't have to be just 2 factors. It can be 2 times 2 times 3 if we wanted to. Those are all smaller numbers that multiply to make 12. Those are all factors. 12. If I asked you to give me the factors of 17, there are none, are there? No. In other words, it is prime. So as we get larger than 10, any of the numbers, most of the numbers are composite numbers, like 12, 14, 15, 16. Those are all composite numbers, right? If I want to divide by a 12, I can divide by a 2, and a 3. I've divided by 12. If I want to divide by 14, I can divide by 2 and a 7, right? 15, divide by 3 and 5. So I don't need divisibility rules for those. Prime numbers like 11, 13, 17, 19, 23. Those are ones we need divisibility rules for. And there are divisibility rules for all of them. Only as we get bigger than 10, they get more and more complex. I won't expect you to remember it, but just to demonstrate how they get more complex, I'll show you the divisibility rule for 11. So the divisibility rule for 11, tell us something's divisible by 11. I start at the first digit and I take every other digit. 2, 6, and 3, what do those add up to make? 11. You got it. 2 plus 6 plus 3 is 11. I take the other digits, the 9, the 7, and the 6. What do those add up to? Add up to 22. Good. So I take the larger of those numbers and subtract the smaller. What's 22 minus 11? 11. So if that result is either 0, 11, or something divisible by 11, that number is divisible by 11. 196,736 divided by 11. Right. That's not a really easy process to do. It's not like 2 where you just look at the last digit or whatever. So it generally doesn't get used. And they get more complicated as we go up. So I'm not even going to show you the ones as we go up. But we need those divisibility rules because we're going to look at factoring. Now, like we saw with the 12, 12 could be factored as 3 times 4 or 2 times 6, or we could do 6 times 2 or 4 times 3, or we could do 2 times 2 times 3. If I ask you to factor 12, how do I know which one you want? Well, generally they ask for what they call prime factors. Prime factoring. Do this. Factor tree. What a factor tree does is it just takes a number and it divides it down smaller and smaller. If I'm starting with 12, what's any number that divides into 12? 3. So if I divide 12 by 3, what's left over? 4. 3 be divided by anything? Right, so I'm going to circle it. Can 4 be divided by anything?
Yes.
What? 2, okay? So if I divide 4 by 2, I'm left with 2. Both of those are prime, so I'm going to circle it. So the prime factoring of 12, what is factoring here? I'm going to write them smallest to largest is 2 times 2 times 3. So if I ask you to prime factor 84, tell me what it equals. What's anything that divides into 84? 4, okay. If we divide 84 by 4, what's left? 21. Perfect. Can 4 be divided by anything?
Yep.
Yes. What can it be divided by?
2.
2. And if we divide by 2, what's left? 2. Both of those are prime, so we're going to circle it. Can 21 be divided by anything?
Yes.
Yes. What's one of them?
7.
7. If we divide by 7, what's left?
3.
We know 7's prime and 3 is prime. 84, if I put those in order, smallest to largest, 2 times 2 times 3 times 7. If I multiply those numbers together, I'll get 84. In fact, those are the smallest numbers we can multiply together to get 84. Remember, we don't count 1 because 1 doesn't do anything. What's prime factor? 630. Yes, so that's, I was just going to say, the first thing I always look for is 10s or 5s because they're easy and they're large numbers. This is divisible by 10 because it ends with 0. If I divide by 10, what's left? 63. Right. So I always look for those 10s and 5s first. Well, the 10 here ends in 0, which means it's still divisible by 5. That's with the 2. Now, both of those are prime. I'm going to circle. Moving on to the 63. Well, can that be divided by 10 or 5?
No.
No. So the next one I usually go for is 2. Can it be divided by 2?
No.
No. Then I look at the 3s and 9s. You got it. I save those till later because we have to add the digits. So I usually wait until try the easy ones first. That does divide by 9. What's left over if we divide by 9?
7.
7. Can 9 be divided by anything?
Yes.
Yes. What's one of them?
3.
3. We divide 9 by 3, we're left with
3.
That's prime. Can 7 be divided by anything?
No.
No, so that is prime. So 630, when we prime factor it, is 2 times 3 times 3, 5 times 7. Make sense?
Yes.
Cool. Why do we care about prime factoring? Well, something called common factors. I have, now let's just do 16 and 24. I want to list all factors, not just the prime factors, but all factors of each. 16 be divided by 2?
Yep.
Yes. 3? 4?
Yes.
Yes. 5?
No.
No. 6?
No.
7?
No.
8?
Yes.
Okay, now the smallest number that we can divide by for factors is 2. 8 is half of 16, so we really can't go any smaller than that. Or any larger than 8, I should say. Anything bigger than 8 is going to cause a fraction or decimal. Can 24 be divided by 2?
Yes.
How about 3? Yes. 4?
Yes.
5?
No.
No. 6?
Yes.
Yes. 7?
Yes.
Careful.
No.
No. 8?
Yes.
Yes. 9?
No.
No. 10?
No.
11?
No.
12?
Yes.
Now 12 is half of 24, so that's the largest number that is divisible by. Again, you divide by 12, you get 2. You can't get anything smaller than that. Those are all the
Is that
factors.
what we just did?
That?
Is it 7? Because 7 times.
So those are all the factors of each. When we want to look at common factors, they both have a 2, both have a 4, and they both have an 8. All the factors of 16 are in common with the 24. But we're not usually interested in all the common factors. We're usually interested in something called the greatest common factor. Greatest, of course, means
8.
largest. Yeah, in this case, that would be the 8. That is the largest of the common factors that they have in common. Well, listing out factors like we did here isn't bad for smaller numbers, but if we had large numbers like 260 or whatever, you'd have to list a lot of factors for that. So we can use our prime factoring. I'm not going to write out greatest common factor. I'm just going to write GCF. We're going to find that greatest common factor by prime factor. 16 and 24. 16, what's anything that goes into 16? 8. What's left if we divide by 8? 2 is prime, so we'll circle. 8 can divide by 2. What's left if we divide by 2? 4. 2 is prime, we'll circle. 4 is 2 and 2. So 16 prime factors to 2 times 2 times 2 times 2. 4 2's multiplied together. 24, what's one thing it divides by? 2, what's left if we divide by 2? 2 is prime, we'll circle. 12 divides by 2, what's left to divide by 2? 6, so 2 is prime. 6 divides by 2, what's left to divide by 2?
I want to say 2, but it's 3.
It's 3, that's.
Not a town.
So it's 2 times 2 times 2 times 3.
So quick question, because I can't think of this correctly. Would it be something like 2 to the power of 3, or would it be 2 to the power of 4?
Okay, so this one, if I wanted to put it, you're thinking exponential notation.
Yeah.
This would be 2 to the power of 4 because there's 4 2's there.
Okay. My brain just wasn't thinking.
This would be 2 to the power of 3 times a 3. The greatest common factor, though.
It'd be 2 then.
Take all the common factors. There's a 2 in common. There's another 2 in common. And another 2 in common. What's 2 times 2 times 2? 8. Well, that's what we found earlier up above to be the greatest common factor. So if I'm looking with more difficult numbers, like, let's see, what do I want to put in here? Let's do 480 and 450, just for fun. Now, I'm a math teacher, so my idea of fun is probably a little bit twisted. My idea of fun is definitely a little bit twisted. So 480, of course, it ends in a 0, so I can divide by 10. Let's go with the bigger numbers first to make it easier. If we divide by 10, what's left? 48, good. Can 10 be divided?
Yes.
By
2.
I know you wanted to say it. What's left is?
Upside down 2.
5. Hey, those are both prime. So we'll circle. 48 can be divided by 2, leaving us with 24. 2 is prime. 24 can be divided by 2, leaving us with 12. The 2 is prime. 12 can be divided by 3, leaving us with 4. And 4, of course, is 2 and 2. So we have 2, 2, 2, 2, and 2. 5 of them. Three and 5. Let's do the 450. Of course, that can be divided by 10. We're going to make it easier on ourselves again. 10 can be divided by 2, leaving us with 5. 45 can be divided by 5. Couldn't say 2 there. 45 divided by 5 is 9. Good. So 5 is prime. 9 divides into 3 times 3. So there we've got 2, 3 and 3, 5 and 5, right? That makes 450. What factors are in common? 2. The 2. Are there any other 2's? No. 3 and 5. 5. 2. That?
I was putting some,
Golf turns?
Yep.
Cool. So 2 times 3 times 5 is
30.
30. So 30 is the greatest common factor of 480 and 450.
I said it first. You didn't. We got a tape. Roll back. Now you're fine. I'm crying over here because of how funny it is.
Let's talk about common multiples. First of all, what is a multiple? stop like that. Third, I saw you go on
Up to 2.
that. Let's say we've got 6. Multiples of 6, or 6 times 1, of course, is 6. 6 times 2 is 12. 6 times 3,
18,
4.
24,
24. 6 times 5,
30.
30. Those are all multiples of 6. You start with a number and you multiply by 1, by 2, by 3, and you work your way up. Or you could just say you count up by the number 6, 12, 18, 24, 30, 36. Not up to. Those are all multiples of 6. We're talking about common multiples. And let's say we're going to do 6 and 8. Well, 6 we already saw was 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and it keeps going, right? We're never going to stop there. For 8, it's going to be what?
8,
8,
16,
16,
25 more,
4,
32,
2,
40,
40,
48,
48,
56.
56. Let's stop there. We found a couple of them that are common. We've got 24 that's a common multiple, 48 that's a common multiple, right? Well, you keep going, there's going to be more of them. There's going to be an infinite number of common multiples. So rather than being interested in just common multiples, we are typically interested in something called the least common multiple. Least, of course, in this case means smallest. You got it. Smallest common multiple of 6 and 8 is 24. And yes, it has a 2. Let's look at our 6 and 8 here and factor them once. Prime factoring is 6 times 3. For 8, 2 and 4, actually 2 times 2 times 2 right here, right? When we look at those factors, are there any in the 6 that the 8 doesn't have?
Yes.
What is it?
3.
3. Well, let's put a 3 down here with the 8. Are there any in the 8 that the 6 doesn't have? Extra 2 2s. If I take 6 times 2 and 2 gives me 4. If I take 8 times the missing 3, I get 4. That is common multiple from up here. We're not going to harp on the factoring stuff here anymore. I'm going to give you guys some homework. Page 26, 1 through 63, the odds. Homework, again, as always, first couple might be kind of easy. Do 1 or 2 of them, skip ahead to the more difficult ones. Tomorrow is test for Unit 1. It is uploaded in Blackboard, should be visible now. So that's all we're planning on for class tomorrow. I'll obviously be at home. Complete the test at some point during the day. Either you can submit it in Blackboard or you can just wait and give it to me on Monday for those of you. Do you have any questions?
If we do the test tonight, do we have to show up to class tomorrow?
No, all we're doing tomorrow is the test. I will log on to the network in case anybody has any questions on the test. If nobody logs in the first 10 or 15 minutes, I'm probably going to disappear. So no, if you have the test done, you don't need to show up. There's nothing that'll be required during class. Other questions? Okay, well, I'll give you the rest of the time for work time if you like it. I'll be here to answer questions.